Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem. Here we have n to the power of 8 minus 121 is equal to 0, and in this problem I can find all the roots of this equation, all the real and complex roots of this equation. So the very first thing we are going to do is here first I can rewrite this equation as, here we have n to the power of 8, and we can write this as n to the power of 4 and its whole square, minus here you have 121, and we will write it as 11 square is equals to 0. After that we will apply here the nice square identity, and you know that about this identity, if we have a squared minus b squared, it is equals to a minus b times of a plus b. So now we can apply here this nice square formula, so that the above inequality will be written in the form of n to the power of 4 minus 11 times of n to the power of 4 plus 11 is equals to 0. After that we will again simplify the term, and we can write the first term as, here you have n to the power of 4, and we will write it as n to the power of 2 and its whole square, minus here you have 11, and we will write it as 11 square root and its whole square times of n to the power of 4 plus 11 is equals to 0. After that we will again apply here this nice formula in the first factor, so that the first factor will be written as n squared minus 11 square root into n squared plus 11 square root times of n to the power of 4 plus 11 is equals to 0. And here you see that we have the three factors, so we will convert this in three cases, so that the first case is, we can write n squared minus 11 square root is equal to 0, and the second case is, we take n squared plus 11 square root is equals to 0, and the third case is, we take n to the power of 4 plus 11 is equals to 0. So I can name this as equation number 1, and this as equation number 2, and this as equation number 2. So I can solve these three equations one by one. So first I can write or solve the equation number 1. So one equation implies that, here you have equation number 1, n square minus 11 square root. So now we move this 11 square root in the right hand side, and you get n square is equals to square root of 11, and you can very well know about the square root sign, and you can write this 11 square root as 11 to the power of 1 over 2. So now we can again, in order to find the value of n, we will take the square root on both of the sides of these terms, and you get square root of n square is equals to 11 to the power of 1 over 2 and its whole square root. So that here this is the square root of square root, and you can write it as 11 to the power of 1 over 2 and its whole power 1 over 2, and these 2 and square are gone, and you get here n is equals to plus minus, here you can write plus minus sign because you can take the square root on both sides, and you get n is equals to plus minus 11 to the power of 1 over 4. So these are the first two real roots of the given equation. So now we solve equation number 2, and equation number 2 is n square plus square root of 11 is equals to 0, and we will solve this equation, so that here you can again move this square root of 11 in the right hand side, and you get n squared is equals to minus square root of 11 So now here we again take the square root on both of the sides, and you get square root of n, and we have plus minus sign, and again you can write this square root as 11 over 2 and its whole square root. So now we will again write this square root as, you have the negative sign under the square root, so it is equals to iota, and you get 11 to the power of 1 over 2 and its whole power 1 over 2 times of iota. And here you get plus minus 11 to the power of 1 over 4 times of iota. So these two and square are gone, and you get the other two roots of the given equations, and these two roots are complex roots or imaginary roots. So now we solve equation number 3. So equation number 3 implies that n to the power of 4 plus 11 is equals to 0. So here you can move this 11 in the right hand side, and you get n to the power of 4 is equals to minus 11. And now you can first take the square root on both of the sides, and you get n to the power of 4 square root and square root of minus 11. So these two and square root are gone, and here you get n squared plus minus, here you have minus sign under the square root, so you know that square root of minus 1 is equals to iota. So now we use this value here, and you get square root of 11 times of iota. And now we break this case in other two parts, and you get n square is equals to square root of 11 iota, and n square is equals to minus square root of 11 iota. So now you again take the square root on these two terms, so that here you get in this form, and these two and square are gone, and here you get n is equals to, here you have, we can make the square root on both of the terms, and you get 11 to the power of 1 over 2, because this square root is equals to 1 over 2, and this 1 over 2 be the top square root. Okay, so that here you have square root of iota. So these two exponents are multiplied by each other, and you get 11 to the power of 1 over 4, and here you have iota to the power of 1 over 2. So here you can again write the plus minus sign, because here we can apply the square root on both of the sides. So these are the other two roots of the given equation. So these roots are imaginary roots. So now similarly we will take again the square root on these two terms, so that you get the terms in this form. So this 2 and square are gone, and here you get n is equals to plus minus minus 1 square root, and square root of 11 is 1 over 2 and its whole square root, and this is square root of iota. So here you get plus minus minus 1 square root is equals to iota, and it will becomes iota to the power of 1 over 11 to the power of 1 over 2 and its whole power 1 over 2, and here you have iota to the power of 1 over 2. So finally you get here plus minus, here these two roots are multiplied by each other, and you get 11 to the power of 1 over 4, and here you have iota to the power of 1, so their bases are same, so its exponents are add, so you get iota to the power of 3 over 2. So this is the other two roots of the given equation. So hence, so finally we can say that this equation has 8 roots, and these roots are n is equals to plus minus 11 to the power of 1 over 4. These are the two real roots, and the other 4 roots are imaginary roots. So these are n is equals to plus minus 11 to the power of 1 over 4 iota, and n is equals to plus minus 11 to the power of 1 over 4 into iota to the power of 1 over 2, and n is equals to plus minus 11 to the power of 1 over 4 into iota to the power of 3 over 2. So these are the 8 roots of the given equation, and this is our final answer. So thank you so much for watching this video. Please subscribe to my channel for more exciting videos.